mechanics, resolving simple forces. Forces are vectors, which means they have both magnitude and direction. So the arrow in this example gives the direction of the force, and in blue 20 newtons is the magnitude of the force. Now in diagrams, forces are always positive. They don't have to be positive when you're solving equations, but on diagrams they have to be positive. So this is not allowed. We have a magnitude of 20 newtons, but the minus here is telling us that the direction of the force should actually be opposite to this arrow. It should be in this direction, like this. This is correct. The force is now positive. Example 1. Okay, so we have an object. There's a 20 Newton force acting to the right, 20 Newton force acting to the left. If I take forces acting towards the right as positive, so this is acting to the right, so that will be 20 newtons. This one is acting to the left, so it's minus 20 newtons. So all I'm doing here is I'm adding the forces that I see on the diagram. So this one's positive, and then the minus 20 comes from here because it's acting in the opposite direction to this arrow here. So overall the forces are balanced, 0 newtons, and the resultant force on the object is 0. Now in this diagram we have forces acting in multiple directions. So I'm going to consider forces acting vertically and then separately consider forces acting horizontally, because these are the two directions I've got in my diagram. So I'm taking the upwards direction as positive. So when I look at the forces vertically, I've got this force which is positive because it's acting upwards, so that's 10 newtons. This one is acting downwards, so it's negative, so you've got minus 10. Overall we get 0 newtons, so the forces are balanced vertically. So now horizontally, forces acting to the right are taken as positive, so I've got 20 newtons there. This one is acting to the left, so this is minus 20. Overall 0 newtons. The forces are balanced horizontally. The resultant force is 0 newtons. There is no overall force acting on the object. Example 2. Again we have forces acting in multiple directions, so I've taken my upwards direction as positive. So looking at forces vertically, or resolving forces vertically, we have 10 newtons and then minus 10, so balanced forces vertically. And then horizontally, anything to the right is positive, so that's 60, and that's going to be minus 20, like so. So we do have an overall force acting horizontally. So again, in the diagram all forces need to be positive, but when we're solving equations you can have negative forces. So we have a resultant force, it's 40 newtons in this direction. Example 3, looking at forces vertically, upwards direction is positive, so it's that 10 minus this 10, 0 newtons, balanced forces vertically. Then horizontally, anything to the right is positive, so it's going to be 20 minus the 80, minus 60 newtons. So the magnitude of the force here is 60 newtons. The minus is telling me it's in the opposite direction to this arrow, so this will be my resultant force. Example 4, I'm taking the downwards direction as positive when I'm resolving forces vertically, and I'm taking the direction to the right as positive when resolving forces horizontally. So resolving vertically, resolving horizontally. So I have 15 minus 10, 5 newtons, and I have 20 minus 20, 0 newtons. So we have a resultant force, it's 5 newtons downwards.